Hello everyone. In this video, I want to talk about monitoring and detecting growth problems and this chart in particular and how we could use this to check for early warnings of growth problems. Now, this is a topic that is usually taught at Key Stage 4. If you do a bit more advanced science, if you were doing triple science, you would go into perhaps a little bit more detail than you would at dual award. But we're going to think about growth in general, and then explain why it's important to monitor and detect particular problems. Now, it's important to recognize that different parts of a fetus and a baby grow at different rates. It's something called allometric growth. Humans are a good example of a species that undergo this allometric growth. So the head, limbs, and the body grow at different rates, resulting in an adult human with proportions that are completely different from those of a newborn baby. Now, it's also important to recognise that diet and exercise can massively influence growth. They're really important factors to consider, but there are occasions where there may be an actual abnormality or disease, not even related to diet or exercise. Even though those two heavily influence growth, there may be an underlying problem. For example, growth hormone, human growth hormone, is produced by the pituitary gland, and it's that stimulates general growth, especially in the long bones. But extremes of height, for example, are usually caused by genes or a hormone imbalance. So it's important to check a baby's length, mass, and head size regularly during the first few months to see if there are any such growth problems, for example. So what I've got here on this chart, so we're going to monitor, I'll just again say those that we would consider. So we look at a baby's length, we consider their mass, and we consider head size. So what we have is something that looks a bit like this chart, very typical chart that I've got over to the right hand side here. This is for boys. So we've got, I'll just go through some of the bits. So we've got length down the side here, and we've got weight on this particular scale. So there's two kind of scales, one for length and one for the weight, and then we've got age going across in that direction there. And what we do is look at measurements every, say, 3 months to work out if there is a problem or not. So what we're going to do is I'm going to give some rough numbers, because this video isn't so much more about growth in general and how you measure growth and gestation, for example. It's more, this video serves more the purpose of looking at growth problems and the use of this growth chart. So what I'm going to do is come up with some rough data for a child, plot it onto this graph, and we'll see how we can use it to see if there's a problem. So let's say here's a set of results that we have. So if we have age in months, and we record the, I think for this one, let's look at mass. So we're going to look at the child's mass in kilograms. So we need some values now. So let's have 0, 3, 6, 9, 12. We'll just have the first few values, and we'll put numbers of, say, 2.5, 5, 6.4, 7.5, 8.8. Let's go random there. So let's say these are the values that are recorded. We look at age 0, so that would be birth here on this particular graph, and I'll do these in, I'll plot this in, I'll do it in red so it's still quite clear to see on this against the blue background. So we look at mass in kilograms, so we're looking at this particular column here. So we've got our mass in kilograms, and if we go up to 2.5 at birth, that's about there. So you just plot an X on the chart where that value would come. Then at 3 months we have a value of 5. At 6 we've got a value of 6.4, which is roughly there. It's not the most accurate plotting, but you kind of get the gist. At 9 we've got a value of about 7.5. So you can see it continues, whilst I'm just putting the red asterisks here, the scale from 8 upwards continues there. So 7.5 we're looking at about there, perhaps at 9 months, and then finally at 12 months we've got 8.8. So 8.8 is perhaps there. Okay, so ideally I should have continued all the way to 36 months, but let's just take this one value here. Let's look at that and explain the importance of that particular value. Now, what you do is you imagine you were to draw a line between all these points, and you look at which percentile it lies nearest to. So these numbers here, that I'll just highlight here, they're the different percentiles. An average clearly is around 50, and this is how it kind of works. If a recorded value for a mass, so let's say we've got a mass here, for example, is at the 25th percentile. So let's say we were, I'm just going to pick a random number, then we'll look at the actual example. So let's say that this line were to coincide with that 25th percentile line. What it means is that that child has the same mass or bigger, so it's the same or bigger, same mass or bigger than 25% of the population. So that's the same as saying they have a mass smaller than 75%. So they are therefore underweight. Outside the range of about 95, the 95th and the 5th percentile, we usually say that that's indicative of a growth problem. So clearly the lower down below 50 you are weight-wise, we're likely to be underweight, and above we're likely to be over. So conversely, if I said we were looking at the 90th percentile, it means that this child would have the same mass or be bigger than 90% of people, which means they're smaller than 10% of people. So that would imply massively that that child is significantly overweight for its age. So now let's look at this actual value that we have here. We're quite close to our 3rd percentile line. So now we're looking at our actual value that we obtained, the red X that I've circled, and we're coming close to our 3rd percentile line. So that means that this child has the same mass or is bigger than only 3% of the population, which means that this child is smaller, has a smaller mass than 97% of the population. So this child is massively underweight. So that's what this graph shows, that this child is massively underweight. And that's how you read one of these growth charts. Now we could have done that with head size, body length, any of those. All you do is to plot the data, you look at which percentile it lies to, follow what I've said about what it means when it lands on that percentile. It means it's the same or bigger than that percent of the population. And then you can pick up on any sort of growth problems that appear to be occurring. Now, there's a whole range of growth disorders, which I'm not going to go into great detail in this video, but certain things that you might be able to detect, for example, going back to what I said previously, are extremes of growth. So gigantism caused by a tumour of the pituitary gland can actually lead to production of excess growth hormone. There's acromegaly, where it's a condition that continues into adulthood, where the bones are no longer capable of increasing in length, but actually grow in thickness. Then, genetics-wise, there's an inherited form of dwarfism called achondroplasia. That's actually a dominant disorder. And I talk about the differences between dominant and recessive disorders in another video. So that you can detect via this sort of method. And then there's pituitary dwarfism, which could be detected. Again, another problem, hormone imbalance caused by the pituitary gland, maybe not secreting enough growth hormone. So there's a whole range of growth disorders that we need to consider. You should always consider diet and exercise, as I said, and how they can influence growth. But it is important, therefore, to use these growth charts to monitor a baby's length, mass and head size regularly to detect one of the things I've spoke about. Okay, I hope all that helps.